Okay, good afternoon. My name is Kim Sampao. I'm the Corporate Relations Director for the Electrical and Computer Engineering Department Heads Association. I'm pleased to welcome you to the ECEDHA Virtual Summit brought to you today by Digi. Before introducing our moderator, I have a few quick housekeeping announcements. We will be accepting questions throughout the presentation, which you can submit using the Q&A text box. To access the Q&A text box, simply click on the Q&A icon at the bottom of the screen. We will address all questions during the last portion of the presentation. Now it is my pleasure to introduce our moderator for today, YC Wang. YC is the Global Director of Academic Programs at Digi. And with that, I will hand it off to you, YC, to get us started.
Thank you so much, Kim. And I also want to introduce my team member, John LeDuc, on the call as well. I'll be doing the introduction, but I am losing my voice a little bit, comes in and out. So John will be helping me during the panel discussion. And so I also like to welcome the panelists for the beginning of this meeting, Sanjeev Datla, and also Professor Ricardo Sanfelice. First of all, let me start sharing my screen and we'll start today's online festivities. Okay, let me see.
Okay, I'll start with the first question here.
No, John, hang on just a second here. Okay. Okay, so today's summit is brought to you by Digi's academic program. A lot of you may have seen this before, but the main thing I want to emphasize is that the Digi academic program is more than just a sales-facing organization within Digi. We also provide a lot of material and information that will be extremely useful for your students when they're working on their projects. And in fact, they're extremely useful for your students even after they have graduated. We have a lot of very educational videos. We have a lot of products online. We have online conversion calculators, education kits, including kit we have built with Machine Chat, who Sanjeev is representing on the call today. And so we're very proud to bring this event to you today and also the speakers. And hopefully you will glean something useful and interesting from today's virtual summit. So let me do a quick speaker introduction here. And Sanjeev and Dr. Sanfelice, I'll give you the chance for you to talk about yourself in a couple of minutes. And then John, after they talk, then we'll move on to the panel discussion. So Sanjeev is the CEO of Machine Chat. Machine Chat is a highly valued IoT partner and also supplier for Digi. Dr. Ricardo Sanfelice is a professor at the University of California, Santa Cruz. They will be the panelists, the dueling panelists for the panel discussion at the beginning of this meeting. And after that, I'll hand the stage over to Dr. Rania Hussain from the University of Washington, where she will talk about her work in the area of hybrid and remote hardware. And then after that, we'll have a quick conclusion. And if you look at the timeline of or agenda on the right-hand side today, that is a rough guideline. So we're not necessarily going to be following it down to the minute or down to the second. But nonetheless, we will start with our dueling panel discussion between Sanjeev and Ricardo. So Sanjeev, would you want to give a quick introduction to who you are and Machine Chat for our audience, please?
Sure. Thank you, YC, and thank you for hosting this event. And good morning or good afternoon to everyone on the call, depending on where you are from. So my name is Sanjeev. I'm founder and CEO of Machine Chat. And my specific background is both hardware and software across distributed computing, network, high-speed networks, as well as processor design. So that's been my background, and been in Silicon Valley and been an entrepreneur, a full-time entrepreneur right now, with both high-speed networking technologies, processor chipsets, both from a hardware and software standpoint. And one of my main interests in starting Machine Chat is making it easy for people to deal with operational data and giving people the tools to make better decisions using operational data. And we'll get into that as we get through this forum. YC.
Okay. Thank you so much, Sanjeev. And Professor Sanfelice, could you introduce yourself?
Good morning, everyone, and thank you, YC and John, for inviting me along with Sanjeev to this very interesting panel. I'm currently a faculty at the University of California, Santa Cruz. I am in the Electrical and Computer Engineering department, and I see some familiar faces. I think I met some of you at the ECE head department meeting a few months ago, which kind of suggests that I will be becoming a department head very soon, in a year from now, here at University of California, Santa Cruz. I currently direct the Center for Cyber Physical Systems Research, and I'm also the grad director at our Electrical and Computer Engineering department. My background is on control systems. I got a PhD from UC Santa Barbara on control theory, and I work on a lot of aspects related to network control and how to design algorithms that can be distributed. Many of these algorithms are designed using models of a system, and we typically use models that are a combination of continuous models and discrete models. So these end up being what we call hybrid systems. And it is a very exciting area, and I'm very excited to be here today to share some of the things that I have seen in the academic side for IoT and some of the challenges that we face. Back to you, YC.
Thank you so much, Professor Sanfelice. So I'm going to hand the reins for moderating this discussion over to my colleague, John. John, please kick off the discussion, and the stage is yours.
Sounds good. Okay, when it comes to trying to connect things to the internet here and whatnot, I'd like to we'll start with the first question that I'd like to ask would be, is it possible to address all the industry needs in a few short years of college education?
I can take the question.
Perhaps Sanjeev, yeah.
Yeah, I can take the question.
Thank you.
I think the way I see it from interns coming into the industry across several companies that have been at, I think universities do a pretty good job on focusing on the core aspects of various pieces of the industry stack. And I believe that the answer is yes. Students can come in better prepared into the industry with their with about 4 years of college education, or for those people who are pursuing both their bachelor's and master's together. The place where I think it gets interesting is how they kind of perceive the industry stack of various components that are out there in the industry. For example, if you look at Internet of Things, though it's a 3-word acronym, it's all about data. And whether you're looking at sensors, if you're looking at low power microcontrollers, low power wireless networks, real-time operating systems, application software and cloud architecture. These are some of the components that students already, they're aware about whether they've built a small application on Amazon. But I think where it would really help would be to show students how they fit into this industry stack, if you will, and how they can plug in what they already know, I think is an interesting aspect of applying the vocabulary and the core concepts that they've picked up as a part of their coursework at universities, and coming into the industry and exactly knowing where they fit in would be super helpful. John?
So, yeah, so what do you guys think about, Ricardo, what would you say to that event? Does that, you guys, does that sync with what you're thinking about?
Yeah, absolutely. I mean, when we look at the training the academia provide to students to be ready for IoT, we have come in ECE, come a long way in providing the foundational aspects, the concepts for the different elements of what an IoT system would be. Maybe we can start kind of grounding ourselves of one view of IoT. Everybody might have a different view of IoT. I would think this is a very general term. The way we try to kind of understand it, at least here at University of California, Santa Cruz, and I've seen this at least in the Northern California area at the universities, the definition, if you will, is that we have devices and components, that they need to communicate between each other. Maybe through cloud networks, maybe through standard wire systems, any kind of protocol, Bluetooth, I2C, whatever it might be, right? But there are the capabilities now that these systems will be interacting with environment, right? So it's not a standard embedded system. Now you have interaction with mechanical components, digital components, objects, humans, animals, you name it, right? So now we have this opportunity to create a system where you have interaction with different disciplines, or requires expertise from different disciplines. And I can name, all the way from big data to security, RFID, physical infrastructure sensors, all the way to policy and regulation. So this builds the IoT, which is a big, enormous kind of endeavor, and in my opinion, system to still be developed, understand how to make it work. But I 100% agree with Sanjeev that many times our students don't see, clearly how to get ready for this industry stack, how to put all the things together. And I think that's what an IoT course, maybe at the senior level for undergrad education, should be doing, which is put together all the elements that are basic concepts, very foundational concepts that I think in ECE we have been taught to our students for many, many years, how to put them all together and build this stack. And what does it mean to have these different industry scenarios that we might need the students to work on once they graduate and solve and materialize the IoT of the future.
Interesting. Okay, there's an awful lot of technologies out there going on. So Professor Sanfelice, there's a tremendous amount of technology out there and so forth with data science and IoT. What should students focus on going forward from your perspective?
Yeah, great question, John. The one thing that I do believe, and there is a lot of room for improvement in most academic programs, is to make these programs to be more multidisciplinary. The opportunity to learn about data that is typically taught in computer science kind of department, and then the standard techniques that we know in electrical and computer engineering needs to also be learned. So there is this kind of cross-fertilization between different departments and different programs that we need to allow our students to be able to go and to tap on the resources that they need. Now, I do think that there is here, in my opinion, a very good opportunity to train the students early on by providing opportunities in industry during their degree. Like for instance, we are very close here, UC Santa Cruz, to Silicon Valley. So having the students go during the summer before their senior year to industry for an internship opens that opportunity to see what's out there, what's that they will need in order to succeed in this market, in this new domain that is being created, and then come back and then design their senior year with the courses that they might take, with the research labs that they might join, and also very importantly, if there is a capstone design course in the institution, like we do have those, they can also shape their capstone senior design project and then go into the details of how to build, this skill set that is so critical these days, and so, in my opinion, multidisciplinary.
Thank you very much. That's good. Is there any perspective from your side from Machine Chat on that?
Yeah, so I would like to add to what Professor Sanfelice just said. One of the things that I've seen when students come to the industry is the general tendency for people around them, the teams, to kind of set them off on baby steps. That's been my experience, trying to plug in, whether it's internships, when you get some students in and you try to plug them into a team. It's the comfort zone of where you apply them. The perspective that I think would be interesting here would be the kind of research that is being done in many of the universities right now. If you look at university as a whole, whether it's like oceanography students working on some research out there, tracking some seal movements and the migration patterns, or people in the agri-tech, looking at how to kind of improve the crop yield for a particular climate type. A university as a whole, I feel that already possesses the entire stack at some scale that is very similar to what people would see in the industry. And I think it might be better for the students to, or the university to provide that cross-department or an environment where people from one space, say, for example, let me take the case of, say, agri-tech. So those are students who are trying to maximize crop yield or kind of come up with the next way of optimizing a particular aspect of agriculture. And they might not be necessarily familiar with various types of sensors out there or the networks out there and how they can collect data from what they do. And those students interacting with the sensor technology or the microelectronics groups that are very familiar, and somebody from the electrical and computer science engineering with the real-time operating system experience and the embedded. When you put these students together, universities already have the environment to create this entire setup that exists in the industry. And I think that gives students to kind of have a complete perspective of the stack that they would see outside. It's not very different when they step into the industry, but at the comfort or the familiarity of their professors and their labs that they're already working with, So that's just been my perception because we've been bringing a lot of interns from the industry, from the universities and colleges into at least like the companies that I kind of worked at. And there's this resistance, on how big of a task you could give them or how you can. So it takes many years for students to kind of get that end-to-end system level perspective that can be created at many of these universities with the research that they're already doing. It's just about that platform within the university to get multiple departments to be looking at data in a different way.
Interesting. Okay, so that's coming from the industry side of that angle. And how about like just like directly say from the university side of things? Well, Professor Ricardo Sanfelice, what would you think about the programs needed to provide the training effectively within the university?
Thanks, John, for the question. And is a being in on this side of the problem, right? It is the universities are very stiff in the sense of how to change programs, and also the instructors, myself, very stiff in terms of updating the material, right? We take a lot of time to prepare a course, and then we probably want to run with that course for many years because of the time invested. So that mentality needs to change. Is a kind of a general view, in my opinion, that we need to be more dynamic, more adaptive. So one way that we have been able to, and I've seen that in many institutions, pretty much anyone in my community have these opportunities, is to teach seminar courses where there is probably not a homework assignment structure as the typical, core courses of a discipline, but it's more open to understand what the literature is about and what industry needs, and then build hands-on projects for that course. So that is something that I think is critical. Now, at the usual kind of program, if you look at the track for a student and you say, which track should a student take to be an expert on IoT? We have some paths for robotics here. We have some paths for machine learning. We don't have one for IoT. And I've seen a few universities, for instance, Northeastern, creating a recent specialization on IoT. And I think that could be a good model for many of us to follow. I'm interested in creating something like that here at Santa Cruz. But what I do believe is that, as I said, in addition to having those seminar courses, we need to be able to excite the instructors, the faculty, to teach courses, to renew the courses, to essentially to revamp, some of the courses that they are teaching, so that the applications of the concepts, of the main concepts, are more oriented towards IoT. We need courses that, in my opinion, are refocused on emerging IoT applications. And one way that this could work could be also by offering technical elective courses, as I say, that the students, after having some experience, some understanding of what they want to do in the future, maybe by going to industry for an internship, can come back and say, okay, the last year of my degree, I would like to focus on this particular technical elective courses that will teach me about security for IoT or networking principles emerging for the IoT, and maybe it's just applications related to automation or timing. There are so many problems there, and there are so many opportunities, but I think we need to make our programs more flexible, and also redesign many of the courses that may be a little bit stale.
Thank you. That was actually very good to hear that. So then, when you take a look with so much out there in the industry, in the IoT industry, whatnot, they say, okay, IoT is the next big thing, right? How real is that? And I'll post that question to Machine Chat. How real is that with all this other stuff that's out there that the universities have to teach?
Yeah, so I think this answer might go against much of the hype that goes out there. I fundamentally, from an IoT standpoint, believe that there's nothing like a real thing like IoT. I think it's a buzzword that got assigned many, many, many years ago. Machine-to-machine communications has been there since almost the beginning of time, or since a serial cable was invented. In terms of communicating between machines and collecting data from machines, right? And IoT, I think, is a short form for many things put together. For example, it's all about operational data and what you do with operational data, how you collect data, how you look at data, how you process large amounts of data. And those are things that are already being done in many forms right now. So if you look at the industry, if you look at what is happening in terms of like consumer IoT. Consumer IoT is everything from smart locks to dog collars to baby monitors to everything gets classified as consumer IoT. And in industrial and commercial IoT, it's about anomaly detection, how you kind of analyze a vibration from a machine or a motor to predict its failure, or PLCs, closed loop control systems. You have things like what you call remote monitoring, remote control kind of an application from an industrial standpoint. But if you look at all of this stuff, it is nothing but low-cost sensors, low-power microcontrollers, wireless networks, and a software stack, whether it is TinyML or you have regular data processing. So the core technology is a bunch of core technologies. I believe that IoT is nothing more than an application of several existing technologies, core technologies working together. So IoT is more of an application of technology, but nothing like a new industry, in my perspective, having seen this over the last 9 years of my career.
So there are things that basically things are getting much easier and easier as we learn how to use the technologies going forward, to your point, I believe. I think that's fantastic. What are some of the current gaps then? I'll just ask this to Ricardo. What are some of the current gaps that students understanding between different universities where they need to get more into the industry and start the with the gap that's in that industry for within each student area?
Yeah, no, I mean, the gaps for students are very large, right? I mean, and that's our fault here in academia. We don't typically train them and reveal to them what's on the industry domain, right, that well. And one way that we can change that is by bringing more speakers to our institutions to give talks about what industry is doing. And we are lucky here in Santa Cruz because we can bring people from Silicon Valley very easily, but still, how to remove that gap, that's a big barrier. I don't have a general solution, but definitely more exposure to industry opportunities. As I said, internships, those are great. Our students really excel at internships. Most of our students here in Santa Cruz get hired in our department, get hired by companies in Silicon Valley, and many of them have already been internship positions there. But the more we can cross from one end to the other, the more we can have industry experts come over and explain the things that they're working on and the challenges. The students will start understanding more how to prepare for it, and also faculty, because not many of us in ECE, maybe I would say at 25%, and I think that is kind of global among ECE departments. Faculty interacting with industry, it's not 50%. It's much lower than that, and that understanding is critical, in my opinion, because if you want to prepare someone for a job, in industry, you better start telling them early in the junior year. I mean, I like to tell the example of many of my graduate students who over the year have been publishing articles in IEEE and Elsevier theoretical journals. But then when they go to industry, when they look for a job outside academia, and that happens, most of my students actually have gone to industry, they face the issue of, the very simple, very important issue, how to program. So over the years, seeing the struggles, we've been starting a little workshop in my lab to not necessarily relate to research 100%, because we do much of our programming in MATLAB, but we started, providing problems and giving them reading assignments to the students to prepare for the exams that they will get when they go to industry interviews, which are very, very challenging. And they're actually the filter. If students in any kind of robotics, autonomy, in this case, systems engineering, doesn't know how to program, it's not going to make it much far in the hiring process unless it's a very specific position. So this is related to programming in general for automation or control of robotics, but this also is skills and impacts how we can make our students marketable for the IoT community, right? And that is something that is not clear how to solve like that.
So we have an awful lot of, let's just say there's a lot of, for the degree programs, there's a limit on how much can be put in there, be covered. This is a question that came in. It says, what should be removed from the traditional ECE degrees to make room for the IoT content? Either professor can look at that.
Yeah, that's a great question. That is a territorial problem as well, right? What can be removed? I mean, just this past Friday, we had Dave Powell from Stanford giving a talk about the history of control. He wrote one of the most popular books on undergraduate control systems. And I had a similar question for him. Over the years, we teach control systems. We start with frequency domain, Laplace domain, body plots, and then we get to state space, maybe at the very end of the course. And his book, actually, chapter 9 actually is the state space chapter. But before that, the students don't understand what the state space is. They've seen some differential equations early on. For the ones that are in the call and are not familiar with state space, essentially state space allows you to handle multivariable systems, large structures of systems with motion, and how to control them. So my question for him was, are you going to write a book where one day we scrap all the material that we don't need because of history, right? And then we just focus on the state of the art? And the question is, and the answer is yes, but people will kill me, right? So that's essentially what happens, in my opinion, is there is this inertia, right? Especially in academic settings that do not really prepare us with tools to actually remove material. So that's why my answer to that question has been, and we've been trying to do that, is to create as many options for the students for their senior year, so that, the first 3 years of undergraduate education, they cover the basics, which, are also maybe up to discussion what would be the basics right now for IoT. But then there is some good flexibility on the last year on what to do, what the students should be focusing on the specialization for IoT. But that's a very, very important question. I appreciate it very much. And I think maybe Sanjeev has a take on that. I don't know what's your take, Sanjeev.
So I think, I did my master's from a school in India called Indian Institute of Science and Center for Electronic Design and Technology. And one thing that I found very unique looking back, hindsight, is the way this department operated, wherein when I got into my the first year for my master's, this department invited probably 20 industries from around the country. And they have a pitch day, like 2 days of pitch day, where the industries came back and said, hey, these are some projects that we have, which are like 2 years out, 3 years out. And each of us got to pick a particular project to work on. And we know that these are projects that these industries or these companies are working on their roadmaps. And rest of the courses that I'd taken through my master's were some piece that would help me deliver that as a product. So this department was very product oriented. So I had to learn like powder coating and welding and operating CNC machines, though my major was electronic design. I had to pick up pieces of this, but I took courses, or I was allowed to take courses to fulfill my credits, master's degree credits, in line with that. So I didn't have to take any courses that I might not be interested in. And every course, whether it was low powered microprocessor design or Wi-Fi chip design, or everything was one piece of that product. So I think sometimes inverting it backwards, I do not know. I'm just speaking from my limited small frame. But I think giving people an early exposure rather than waiting for the final year, I think bringing some of that exposure into the first year, though it might be overwhelming for a percentage of students, but for the larger community of students coming into engineering fields or just in the university college first year, giving them an early perspective of the world after this might give them a better perspective on how they need to plan and where their interests are, and giving them a little bit of flexibility on what they can pick and choose to kind of lay their own path through the lawn, the walkway through the lawn, I think can also help, is my perspective, Dr. Sanfelice.
That's a great point. Yeah. Thank you.
It's pretty good. So something that comes up here too that I've seen that came through here is, you know, with the IoT being such a wide thing to kind of cover in different areas, you know, the end nodes and whatnot and so forth, you know, they're in the cloud and whatnot. What about security and any lag time they might have? And when you start getting into AI with all of this being connected through IoT, what would you say about how to address that?
I think a lot of the John, I'll take the question. So a lot of the stuff that is already being done, I mean, there's nothing special for IoT per se. I mean, all the security concepts from networking standpoint that you apply to regular computers, whether it's a PC or it's a supercomputer sitting behind 3 layers or 5 layers of firewalls, the security still remains the same. The concepts remain the same. The thing with the IoT is, you know, you're trying to do what typically was done on a very large computer or something with a large amounts of processing power now gets done on a microcontroller, right? So like if you have something like a ESP32 Wi-Fi chip, which is about, you know, a few dollars, microcontroller with 256 kilobytes of RAM, and suddenly trying to implement a security stack on top of a small microcontroller, something that was done years and years ago. There are like thousands and thousands of papers published out there in the community to do it on your everyday computers. And now suddenly trying to take that and implement that on a microcontroller is where most of the fun and challenge is in the space, you know, trying to take a TCP stack that requires a ton of code, and suddenly you have to reduce it to run on a microcontroller with 16 kilobytes. When you start stripping out the stack, somebody needs to know that the code that you have to remove to make your software fit into a microcontroller, a sensors microcontroller, you're removing the right pieces and not creating security holes. So there's nothing, from my perspective, there's nothing new to be learned here. It's about how do you take what you've already learned and apply it in a very constrained network and a compute resource environment, is where the whole fun and challenge of this whole IoT space is, in my perspective.
There it is. That's good. Yeah. So, okay. So when you start putting everything all together here and whatnot, when the students are going out to the industry and whatnot, you know, what would you say that the next thing now is for IoT opportunities for students when they graduate?
I think having an understanding of how what people are using data for, in terms of whether you're looking at anomaly detection or you're looking at what are things that you're predicting, being aware of data and the importance of data. How do you collect data? How do you apply data? What are different types of sensors out there? You know, what are some of the machine learning techniques out there in a constrained space that are applicable in a constrained space? Those would add tremendous value to the students as they come in. Those are assets that they can bring in. And that's an intersection where I believe that students can come in with a very fresh perspective that industry veterans struggle to kind of unlearn and relearn. And when people come in with, the new sensors that are available, the type of data that you could collect, the type of algorithms out there, this is something that's from the depth of research that happens in the industry. I think they can definitely bring in a lot of value in that space.
So, Professor Ricardo, your thoughts to what Sanfelice said? Sanjeev said, sorry. Any thoughts?
Yeah, no, I 100% agree with what he was saying. I think the feedback that the students will get from participating in industry activities is just very, very significant, very, very important. And the good news is that most academic institutions have mechanisms and interest to engage with industry in order to build these opportunities. So one opportunity could be to create an advisory board, right, that involves industry partners in the IoT kind of domain, and then come up with opportunities for them. I do think that the students are very excited. These are, it's a no-brainer for them to be interested in working on these problems. We see that, as I said, we have a capstone senior design project, and last Wednesday we have our review meeting. We filled up a whole barn. Actually, we have our event in a barn here on campus, and it was really, really exciting. We had a lot of industry partners coming, and the students see that. They see the future is there, the opportunity is there, and I don't think what we know, all of us, is this gap, is how to get there, right? John, you asked about the gap. How do you make that transition? How do you prepare for it well? And I think that's one of the problems we need to solve, and I think an advisory board will be very helpful.
And Ricardo, Professor Ricardo, did you say that doing some of the internships can help through some of that and whatnot?
Yeah, I think so. I've seen it myself. Students doing very, very well. Also participating in open houses where we have a lot of industry folks come in and tell us about their opportunities. They collect their resume and they interact with the students, and they learn also about internships and full-time jobs. But also what Sanjeev was saying is given that opportunity early on in the first couple of years, freshman, sophomore, I think that will also go a long way to have them think about for that future. Now, one question, maybe not for Sanjeev necessarily, but maybe for people in the audience, is how much of graduate degree would IoT require in practice, right? Because there's another opportunity here, which are these accelerated master programs. So for instance, many institutions, I know we have one, we have a program called a 4+1. So with one more year of coursework and research, depending on the track that the student takes, then they can graduate with an MS. In this case, it will be an MS in electrical and computer engineering, but maybe in the future, they could be with an emphasis on IoT. And if this is something that there is somewhat interest in industry because of the need of the formation of the future hires is, then that should be fed back to academia, and then we should probably prepare for that better.
Perfect. That sounds good. And what a great conversation here between you guys and working the angle for all these students that need to learn more and more than what they've been in the past. So then I guess what we'll do is we'll introduce Renee in. I think she's on right now for us. And Professor Renee Hussein, I believe. And then YC, did you want to introduce anything else?
Yes, absolutely. So Sanjeev and Professor Sanfelice, I really appreciate your very candid feedback. Just as a closing remark here, I feel that in addition to in addition to coursework, students should be exposed to the industry at as early as possible, even going to, for example, trade shows. I know here in San Jose, we are going to have the Sensors Expo happening very, very soon. And trade shows like this, even if the student is, you know, a freshman or sophomore, they can go in there. They typically have discounted rates for students, but the more important thing is for them to walk around, chat with people at various booths, and you know, just talk engineering, even if they don't understand all the keywords, but start as early as possible in this, essentially this immersion, and this will help in the understanding, as in how and what they have to pick up, where they want to go. Because to tell you quite frankly, today we're talking about IoT, but electrical and computer engineering is such a wide discipline. We can talk about IoT today, and we can have something on you know, electric machinery on the flip side, right? Or image processing, and there's a whole bunch of topics. And the most important thing, I think, is early immersion as much as possible, and then I think this will help universities on getting the students ready for the you know, the core curriculum when they do get there. So anyway, thank you so much, Dr. Sanfelice and Sanjeev. And I think we will be moving on to the next speaker now, unless there are further questions. I'm looking at the chat window real quick. I don't think so. Okay, so next up is Professor Rania Hussain from the University of Washington. Professor Hussain recently won a recognition award from ECEDHA at the New Orleans ECEDHA conference. I've invited her to come back and talk more about her work. We're going to switch gears a little bit from IoT to teaching digital logic to students and preparing them as early as possible, and maybe with hardware that is easily accessible as well. So Professor Hussain, without further ado, could you do an introduction to yourself and kick off your portion of the presentation? Thank you.
Yeah, hi everyone. Thank you, YC, for the introduction, and thank you for inviting me. And thank you all for being here. It's a pleasure to be on the summit for ECEDHA and ECEDHA audience. I will start sharing my screen. So, okay. All right, so just double checking, do you see this in the presentation mode?
Yes.
Yes,
yes,
thank you for
yes.
the confirmation. So I would like to talk today about what we are doing in my lab. Briefly, I am an associate teaching professor in the Department of Electrical and Computer Engineering at the University of Washington. I would like to talk about the remote learning. Although remote learning has been associated with the pandemic, and now we are moving beyond the pandemic. So what would be the future look like from my perspective and my team's perspective? So basically, what we are looking at is how we can provide access similar to what students experienced during the pandemic, but still, you know, remotely provide remote access to hardware, industry-grade hardware, which is what students experience. And I want to first start to talk a little bit about what we have done as a pilot project during the pandemic, and then how this evolved to the remote hub lab. So the remote hub lab is founded in 2021 in collaboration with Labs Land. Our research focus is virtualization, remote engineering, and equitable access to education technologies. And we have, in addition to the remote hardware, which was shown in the previous slide in the picture, that was a remote FPGA lab. Comes with the remote FPGA lab some features, web interface features that allow students to work on several projects, whether the project requires some breadboarding or audio, interfacing audio with FPGA, or video, or VGA, or simple keys and switches and LEDs. So I will expand on that more. In 2020, when we were hit by the pandemic, we had a pilot project where, well, let's just see if this is going to even work. Let's see if the students can get the same or as close as possible to an experience that they would have in a real classroom, where they typically get access to physical lab kits. So in my course, in my advanced digital design course, it's a junior level course, 371. I implemented that idea of, instead of giving the students the kits, the physical kits, let's just have them finish all their assignments using the remote lab. And I was, as an educator, I wasn't sure if this is really gonna compromise any of the students' learning outcomes. So in a study, I compared what students provided, the outcome of that course, by comparing just one assignment. Took one assignment done through the winter 2020, where the remote lab was first used, and then compared to the same assignment the students used to do prior to the pandemic, prior using the remote lab, where they had access to the physical lab kits. And this study, it's highlighted down there for anyone who is interested to check out the paper and read the details about the study. But briefly, this was grounded in Bloom's taxonomy to study the learning, how students learned, and what they produced in the two different settings. And basically, the students, the results showed that the learning outcome was not compromised. At all. The Bloom's taxonomy briefly is 6 levels. So in one of the levels in particular, which is the analysis, the students showed better and significant higher scores in the analyze, because using the remote lab pushed them towards focusing on using the verification tools. So they spend the time thinking about their design offline, and used the Quarter software and to develop offline. And then also, more importantly, is the simulation aspect, to verify before they take up their work, their code, and put it on a real FPGA. What I noticed in the past, what typically was happening was students get a hold of the FPGA board, and then they write the code, and then they send it right to the FPGA. And that's mostly what they were hoping for. Okay, maybe let's see, it works. If it doesn't work, then let's just go and work more on the code. And the simulation verification tools were typically skipped, or if not completely skipped, wasn't a focus for students. So that study proved that the concept that using the remote lab was not a compromise of the students' learning experience. And in fact, it helped them in at least one of the Bloom's taxonomy levels. So from that, how can we say, okay, now is this really good just for the pandemic or not? And we went back to the University of Washington in-person teaching, and I continue to use the remote lab in my course. And then part of the remote hub lab research focus, as I introduced it, is looking at equitable access in engineering education. So we looked at this question: how can we advance it to be more accessible and scalable in the post-pandemic context? And we, one of the projects that we are worked on, and the one that is the focus of this particular talk, is the BEADLE project. And BEADLE stands for Bringing Equitable Access to Digital Logic and Engineering. We have other projects going on, and you can find more when you visit the RH Lab website. But as I mentioned today, our focus is the BEADLE project. What is that? Basically, what we did is we developed 7 introductory digital logic labs to be completely implemented on the remote lab. And this introductory digital logic, it's different from the one that I used in the pilot project to prove the concept that the learning outcome will not be compromised. So this is more geared towards maybe first-year students, engineering students, or community colleges, and the community colleges, or could be even students in high school. So so these are the labs, and they are also available on the BEADLE website. No prior experience is needed for a student to take the curriculum and go through it. We really wanted the idea that we want to empower anyone who is curious or who is looking for maybe a future career in engineering and digital design, or maybe getting to a program, 4 years program. So how can we empower them to explore that without the worry, or without thinking, oh, I must need an industry grade hardware to be able to develop myself in that area? And that we don't, we say, oh, you don't need to worry about that. You can remotely access the hardware that you need, and you just have the curriculum to go through it. So the curriculum content briefly, but again, all the info and all the labs are posted. This is an open source curriculum. So we have the first lab. The first lab is basically getting started, knowing, download the software, and creating accounts to access the remote lab and all of that. And then we start introduction to gates and digital logic, binary numbers, truth tables, Boolean algebra and K-maps. And then we start talking about the FPGA and basic introduction to system Verilog. And then we go into the sequential logic for nested machines. And then we wrap this up with the project that puts all these pieces into one final project that students complete. Well, in order to do that, and here is some screenshots of what's in the lab, and basically they build on each lab. They build on the previous one, so students grow their knowledge as they move through the labs, and they are all hands-on. So the labs are all designed for students to finish hands-on exercises on the remote lab. And even the, knowing the Boolean algebra that we typically do in the classroom, in the typical classroom, by using the K-maps and Boolean algebra, and just finish it with paper and pencil, or just going through it theoretically. What we're doing here in the BEDL project is that students can actually use that and in hands-on exercises on the remote lab, and get to see what this K-map, how can I solve a K-map interactively. So that is part of the features of the BEDL project. So these are the remote lab tools that comes with the BEDL project. We have the digital trainer. The digital trainer is like a game activity where students experience what is a truth table. So they are challenged to find out, oh, so you see here some lights going on. What's your guess? What kind of gate, for example? What kind of what kind of gate that would be? So that is an example of that digital trainer. We also have the Bool designer, and the Bool designer that complements the labs, that talks about the Boolean algebra and the K-maps. And we have the Intel G1 SoC, where students get to access real FPGA boards in the RH lab. And when they access it, then of course they will be writing system Verilog, and the curriculum walks them through how they can do that and how can they create their project on Quartus, compile it, and that also comes with some YouTube videos that is also part of the BEDL project. So labs 0 to 3 basically based on the digital trainer, and the next labs 3 to 6, the Bool designer, Bool web, and then 4 to 6 are using the real FPGA. So this is some screenshots of what the digital trainer looks like, the web interface for it. And here are screenshots of labs, some parts of the labs that uses the digital trainer. And this is the Bool designer. And the Bool designer is an interface where students can actually try Boolean expressions and see what the Boolean expressions. So here at the bottom, for example, they identify how many inputs, how many outputs their truth table would look like, and then from there, here is a truth table, and here is from the truth table how can they do K-map, and and then after that, what does that come down to as far as reducing and optimizing the logic into circuits? So this tool is part of the BEDL project to complement the curriculum. And then the third tool is using real FPGA board, where students here can write in an editor, code editor. They can write the code in system Verilog, and they are able to compile it. And then once they compile and everything works, then they can log into the remote lab by here, this is reserving means it's reserving an FPGA board for the students. And then after that, they get to the remote lab platform where they have access. So this is an FPGA board, DE1 SoC, Intel's D1 SoC. So this is located in the remote hub lab at University of Washington, and students here, they have access to virtual keys and switches to emulate the switches and the keys on the real FPGA board, and and then they see the output on the LEDs on the FPGA board itself. And then they can also use the 7-segment displays in, I believe, in one of the labs, and they would be using them as well. So we already got people to test the curriculum. One of them is a high schooler, Riley, and he shared with us this quote about his experience going over the curriculum by himself without any assistance. So, and we also have a testimony from Cynthia. Cynthia tested the curriculum before we release it. She's part of the RHL Beetle team, and she gave us also her feedback about the curriculum. So from there, after the curriculum is developed, now what would be our next step? So next step, we are looking for partnership with community colleges for potential adoption. We are looking for not just community colleges, any colleges or 4-year colleges. And in particular, we are interested in institutions that are in underserved communities. We would like to provide access to this hardware. I mean, the D1 SoC is typically, I would say, maybe $300. And so if we're looking at, on a scale, if we have large number of students, then that could be quite a budget. So we are interested to partner with institutions in underserved and underrepresented communities. We want to try this curriculum and take it, take it to the next level to help us in the mission of promoting equitable access to educational technologies. So we would like to investigate that more. And our next step towards that is to have partnership with community colleges or even K-12. We are interested in collaboration with educators on next generations of curriculum development, and also on research projects on virtualization, remote engineering, and equitable access. Our next step also, this is one of our future projects that we are working to realize and make it happen, hopefully soon in the near future, is that we would like to provide a breadboard. If you notice, maybe in my second or third slide, I showed some web features, and one of the web features was a breadboard. Now that breadboard there is just a proof of concept. It's very primitive, doesn't have any a lot of features other than just a couple of switches and LEDs, just to prove the concept that can we interface a virtual environment with a real physical hardware. And students in my course used that, but there is definitely a lot of improvement that needs to be done. And one of them is the ability to build actual circuits. So that is what we are working on to hopefully have it done in the near future, and hopefully to complement it, maybe the next generation or the next release of the Beetle with the ability to build circuits and integrate it with the physical FPGA boards. So this is briefly the butterfly, the RHL butterfly. And I would like to thank everyone involved in the RH Beetle project. And here they are, University of Washington, Florence, she's my student researcher. Testers who tested the curriculum, Justine, Bailey, and Cynthia Rosales from Intel Corporation, and Kylie. Kylie is a first-year student, undeclared engineering. So that was like a great tester. Like, okay, if you don't have any prior knowledge of digital design, can you take this curriculum? And then also the Riley, who provided testimonial, and then the developers from LabsLand team, Pablo, Orduna, and Luis. And I would like to thank the sponsor of the RH Beetle project, Intel Corporation, for funding this project. And with that, I am like to open it for questions.
Thank you so much for the presentation, Professor Hussein. So we have a question from Lin Cheng. So the question in the chat window: for the first year student, is the DE1 SoC board more accessible than other Altera DE boards, such as the DE2? So I'm going to do a little interpretation of this as an accessible, as an easier to use, or having more hardware, more accessories on it. So would this be something you can answer, or would Pablo on the call be able to answer that? Or I see people from Intel as well. I can open this up.
Yeah, I would like to understand more about, for first year students, the DE1 SoC board more accessible. I would like, well, that is a very good question. We use DE1 SoC board primarily because that is what we have been using at the University of Washington, and it is a very powerful board. That doesn't mean that this cannot be done, or doesn't mean that you cannot have like a remote lab with a different FPGA board. That's not the case at all. But if the question here is like why we chose the DE1 SoC board over others, it's just, I guess, because we have been using it, and it proved success in a junior level advanced digital design course. And so if it has a lot to offer to an advanced course, then it will, whatever it can offer can also translate to like lower level digital design course. I don't know if this is what you are looking for, but if this doesn't answer your question, please elaborate.
Yeah, so thank you. This is Lin Cheng who asked the question. So I understand that, first of all, thank you for the presentation and trying to answer that question. I guess so I've used D0 Nano and also like some other D2 series of boards before. I have not used the D1 SoC. Since well, I can infer kind of from the name that it actually has a system on chip functionality, and I could imagine if you use that from the very first year, then in a particular school, then you can have like higher level system level or embedded systems class continue to use board. That forms a very nice, cohort of courses using one hardware platform. Is that the case?
Well, I would say yes, but I also want to say that we have not, like, it wasn't like, oh, we tried the GE Nano and the GE1 SoC, and now we're gonna go with the GE1 SoC. So I don't want to discredit any other FPGA board, but the GE1 SoC, yes, it is powerful. And again, if we can train students or let them get used to that level of, of hardware from early on, then let's say the students come into the 4 years college and happens to be at the University of Washington or any institution uses GE1 SoC, then they have already used it. But again, it doesn't mean that if they are using a different FPGA board, they won't get the same experience, especially with this curriculum. This curriculum, I think it can really work with any FPGA board. It's not just for GE1 SoC.
Okay, thank you. Just a quick follow-up question. It seems, the handouts looks very nice. Are there any like troubleshooting or like, students need help because this is more like done remotely? How do you handle those? And what are the best ways that you find useful to address students' questions, especially when they do troubleshooting on for example, writing the very long code and say diagnose problems with their output, things like that.
I see. So currently the curriculum is developed to be again, open source. So any institution interested to adopt it, then we will rely on the instructors who will be teaching the course to provide the assistance needed, and they can always reach out to us for any questions about the curriculum or however we can help. And then also we are providing for instructors instructors resources. So we have a solution manual for the labs to be offered to the instructors who decide to adopt the curriculum. In addition to, also instructors can get Word documents for these labs if they decide to adopt. That is the current plan of how we can provide assistance. But it is something that it's possible to explore more on a larger scale of providing assistance maybe through a web forum or web community or online community for the middle project. So it's something to be explored. But in the meantime, we will rely on the instructors of record who adopt the curriculum.
I guess I should ask it more specifically. That is, since this part of this curriculum or this material is mostly carried out remotely, there's a big difference between doing this remotely versus teach them face to face. And then if there are any problems with hands-on process, you can fix it. So I'm asking in general, since you've done this, several times, what are the takeaway messages, when you doing this remotely, how to address students' questions? I guess that's me, right? Yeah.
I see. I think I should have clarified when I used not that particular curriculum, but the remote lab. It was done. I was still providing support to students through office hours. We still had synchronous, when we were online, we had synchronous Zoom lectures, when we went back in person, I have, in-person lectures, and it's exactly as if you are offering and delivering the curriculum in person, except the only difference is instead of giving students the lab kits, physical lab kits, they will go on the remote lab platform and execute. But still, of course, they have a lot of questions. Whether the question is about the the concepts, or question on the lab, or how can they system Verilog questions, or debugging issues, or simulation issues. So all of that, then they have us. They have the instruction team, the whole instruction team available to answer these questions. And of course, before we even release any lab to students, we test it and make sure that there is no flaws, nothing that that can hinder the students' experience. But still, there is always questions coming up, and but we were able to address them. We have not had an issue where students got stuck and they couldn't move on, or they couldn't finish the course successfully, or any of that. So they had us.
I see. So does the student evaluation says anything like, for example, does it say something like, they have something in hand and doing something like, do they complain at all, or do they satisfied with this kind of like instruction mode, in general?
That is a very good question. Honestly, I had students, who were, saying both. So, but the first time we had the pilot project in 2020, we in the student evaluation, there was one particular question, and I just want to pull it up. But it basically asked students on a scale from, of course, 0 to 5, their experience using the remote lab for the first time. And I think statistically, I had maybe 40-ish students out of 70 total, or 60-ish completed the survey. And that question came median 4.3 or around that, rating their experience with using the remote lab out of 5. So it was over 4. So they rated it high. But I also had students who still think that, well, why do we use that? I mean, I just give me the FPGA board in my hand, because I don't want to be limited to the time that the remote lab offers, because they get about 2 to 3 minutes to check out their code on a real FPGA board. But then I tell them, I mean, that's not the point, really. If the point of prototyping with FPGA is, you need to think about the design, you need to think about the verification. And then even in the industry, you may not, when you go to the industry, you may not even have, access, not that, they can give you access to real hardware, but it could be just because of, your role there, that you really rely a lot on the modeling and the simulation aspect. So many students start to get it, like, okay, this is because of the learning aspect of it, not because we want to just take away physical boards from you and trouble you with just, go to remote lab. At the University of Washington, we don't have a problem giving physical boards to all our students. We don't have a problem with that at all. But I still chose to go for the remote lab because I wanted to focus on the real objective of prototyping with FPGA. So
I see. Okay.
yeah, hope
Yeah.
this answers your question.
Yeah. I thought that student might feel that maybe they have more time, like at their own
Yes.
pace, at their own time, like to, to do the labs rather than, yeah. But thank you for the elaborations.
Yeah, of course, my pleasure. I see a question here in the chat. How many FPGA boards can be accessed simultaneously in your lab? So all the FPGA boards, or each FPGA board can be accessed by one student at a time. But the students get around 3 minutes. And then after that, they would be, their session with that particular FPGA board will end. And then if they need to use it again, then they will be in a queue. Based on my experience, I think the maximum wait time that students reported waiting for a board was in a matter of few seconds. So we never had a problem where students kept waiting, and not getting a board. That never happened in my experience. And also, the students access it at different times. They have 24/7. So they don't have to be all using it at the same time. But even if they do, the system, we have not had any problem. Like students, like congestion on the network or anything. And we have actually some data about like how many students use the session and how many students are using it at a time, and the boards that have been accessed, and all of that. So we have never had a problem, fortunately, with that contention or congestion problem. Does this answer your question, Doug?
Okay, I see that we're closing in at the top of the hour. So YC, did you want to give some final thoughts?
Well, thank you so much, Professor Hussein, for the very, very in-depth presentation on Project Beto, and also handling the questions. Those are really good questions as well. So DigiKey definitely is very interested in supporting you with Project Beto in whatever form that you may require. And I would also like to thank the support crew on the meeting as well, who may have stayed quiet. But Pablo, thank you so much for being on this meeting. Feel free to shoot me any questions you may have. If you have any questions about what we presented earlier on with the dueling panel discussion, or anything regarding remote hardware and Project Beto, we definitely are interested in hearing from you. Professor Hussein, could you put your email address into the chat window, please? And I'll put my email address into the chat window. Also, thank you very much, Kim, for giving us the opportunity to do a short presentation to all the wonderful folks we met at ECEDHA this year. So then we're at the top of the hour.
Great. Thank you so much, YC, and to all the speakers. On behalf of ECEDHA, we'd really like to thank DigiKey for making summits like this possible. It was an outstanding discussion, and we look forward to posting it on the website for on-demand viewing. Please visit the website. We're at ECEDHA.org, where you can access the on-demand version of this webinar, which will be available soon, and other programs from ECEDHA. Thank you all again, and have a great day.